This is day 1 of Unit 4 Part 2, which is, it's still Unit 4 because we're still talking about circles and other things that are round, spheres, which will be coming up in Part 3. But we are moving away from just talking about angles and arcs to include chords. We're going to start talking about the relationships between these segments that go from one side of the circle to the other. They're called chords. And most of what we're going to look at today is just sort of common sense. I think it's pretty easy. So here we go. Look at number 1, for example. We're supposed to find the measure of arc BC. One of the properties of a chord is if the chords are congruent, then the arcs that they intercept are also congruent. So because AC is congruent to CB, those chords, then that means that arc AC is also congruent to arc CB. So these are congruent. Alrighty then. So if I start by subtracting from 360, alright, that'll tell me how much is left for the red part, but because they're congruent, I will just divide by 2. Okay, that is 244. So that's 244 degrees for all of this, so I will divide by 2, and so of course that is 122 degrees for AC and CB each. But we are supposed to find the measure of arc BC, and that is 122 degrees. Okay, no problem. So looking at number 2, we're supposed to find arc LM. Again, all 4 of these chords are the same. That means all 4 of these arcs are the same. So I can just take 360 and divide by 4. And that's, of course, going to be 90. So that's all there is to that. LM is 90 degrees, and that was just 360 split up evenly 4 ways. Okay, number 3. Okay, there is another sort of set of properties that we learned about with these chords, and basically it is this. These 3 things are closely related. Let me zoom in just a little bit. Diameter, perpendicular, and bisector. And the way these 3 things are related is if a chord has any 2 of these properties, it's also going to have the 3rd. So in other words, if a chord is a perpendicular bisector, it must also be the diameter. If you have a diameter that's perpendicular, it also must be a bisector. Now, what does bisector mean? Bisecting is to cut something exactly in half. Okay, so bisector is going to be cutting some other chord right down the middle. And so what did I not say yet? If I have a diameter that is a bisector, then I can conclude it is perpendicular. So for example, look at these 3 cases. Okay, in each of these cases, I'm giving you 2 pieces of information. And so if I ask you what can we conclude, I'm looking for that 3rd thing. Okay, in other words, I'm giving you 2 of these, and the 3rd one you can infer. So, looking at this first case, what can we conclude? Well, I'm giving you that this chord RM is a perpendicular, see the 90 degrees, bisector, because it's splitting this in half. So because this is a perpendicular bisector, I can conclude that it is the diameter. So segment RM is the diameter. Now on this one, see this dot in the middle? The first picture, no dot. That dot, of course, is the center of the circle. So that's my way of giving you that segment RM is the diameter. So I'm giving you it's a diameter, and I'm also telling you that it's a bisector. See the two equal pieces? So we can conclude that it is perpendicular. We know, even though it's not shown, that RM must be perpendicular to DK. And on this one, the dot again tells us that RM is the diameter, and I'm giving you that it's perpendicular, so we can conclude that it must also be a bisector. So that means, you know what, I really need a third letter in there. Okay, let me call this point B here at the center. So we can conclude that DB is equal to BK because it must be a bisector. All right, so keep that in your brain. So as you look at problem number 3, you see the dot. That means PR is the diameter, and it is perpendicular. So we can conclude that it must also be a bisector. So in other words, these two segments should be equal. That means that this should be 11 on this side. So that makes QS a total of 22. All right, number 4. The measure of arc AC. Well, similar to before, I have 130, so if I start with 360 and subtract that, okay, that's going to leave me with 230. But that's to be shared equally between these two arcs, so I would divide by 2, so that's going to be 115 each. So that means this is 115 degrees, and this is 115, degrees. All right, that means AC is 115 degrees. Number 5. Well, let's see. We're supposed to find the measure of arc PQR. Well, because these two, the chords are congruent, this is a bisector. So in other words, if this arc PQ is 40, then this arc QR must also be 40. So PQR must be 80 degrees. Number 6, the measure of arc KLM. Okay, KLM is the arc that goes all the way around here. Because this is 90 degrees, then we know this whole thing is a rectangle. Okay, so we have a rectangle happening, so that means all of these opposite sides are congruent. All right, so if this side over here on the left is 38, then that means this arc over here must be 38. It's a rectangle, so these chords are congruent, so these arcs are congruent. If this is 142 up here, this is going to be 142 degrees down here. Anyway, the thing that we're supposed to find, arc KLM, is this. All right, there's point K, so K to L to M would be like that. So it's just 142 plus 38. That's it. So that is 180 degrees. Okay, that doesn't really look like a plus sign, but anyway, that's where it came from. That plus that. Number 7. Find the value of x. Well, this is a perpendicular diameter, so it must be a bisector. So these two pieces must be equal. So I will simply set them equal to each other. That's what we do, man. Let me make this smaller so I can do the math. So I will go like this: 12x plus 7 is equal to 3x plus 16. Subtracting 3x from both sides, that's going to give me 9x plus 7 is equal to 16. Subtracting 7 from both sides, so that's going to give me 9x is equal to 9. Dividing by 9 on both sides, and that's going to give me x equals 1. So yeah, that's it. X is 1. Okay, so number 8. Same type of deal. This is actually another property of a chord. If the distances from the center are the same, then the chords must be congruent. So that means, again, these two should be equal to each other. So I can just go 3x minus 11 should equal x plus 9. Subtracting x from both sides, that gives me 2x minus 11 equals 9. Adding 11 to both sides, and I get 2x is equal to 20. So if I divide by 2, of course, I get x equals 10. All right, so that is how you do number 8. Number 9. Same thing as before. These two segments should be equal to each other because I have a perpendicular diameter. It must be a bisector. So I will once again set these equal to each other. So I can just go 9x minus 3 equals 7x plus 5. If I subtract 7x from both sides, that's going to give me 2x minus 3 is equal to 5. If I add 3 to both sides, that's going to give me 2x is equal to 8. If I divide by 2 on both sides, x is 4. Okay. That's number 9. All right, number 10. The distances from the center are the same, so the chords are the same. So, same thing as before. We will say 13x. Now I'll go with the 6x minus 5 should equal this 13 plus 4x. Those should be the same. If I subtract 4x from both sides, that gives me 2x minus 5 is equal to 13. Add 5 to both sides, and 2x is equal to 18. Divide by 2, and x equals 9. All right, number 11. Since the chords are the same, that means their distances from the center must be the same. So here we go again. 7x minus 10 should equal 3x plus 6. Subtract 3x from both sides. That gives me 4x minus 10 is equal to 6. Add 10. That gives me 4x is equal to 16. Divide by 4, and I get x equals 4. That's the answer to number 11. Number 12. Well, these are both radii in a circle, so we don't really need a special property for that. Of course, these radii will be equal. So you guessed it, I'm going to set them equal to each other once again. So I will have 14x minus 9 is equal to 9x plus 21. Subtract the 9. Okay, so that's going to give me 5x minus 9 is equal to 21. It's time to add 9 to both sides. So that's going to give me 5x equals 30. Dividing by 5 on both sides, that's going to give me x equals 6. Okay, so this lesson has not been particularly tough, but it's good to lay the foundation. Last problem, a little error analysis. Explain what is wrong with this diagram of circle X. By the way, circles are named by their center point. So if I talk about circle X, I'm talking about the circle with center X. Okay, let's see. What's wrong with this picture? Can you tell me? Can you see what's wrong? Where's Waldo? What's wrong? Well, hopefully you're noticing. See these congruent marks? So PQ here and RS, those segments, those chords, are the same distance from the center. And we just learned that if two chords are the same distance from the center, then they should be congruent. All right, but of course, this chord is 16, while this chord is 18. So they should be the same. So that is what's wrong with this picture. Okay, the PQ and RS should be the same. Segment PQ and segment RS should be congruent, but they are not. Okay, and there you have it. That's our lesson for today, and I hope it was helpful to you. If it was, please give me that thumbs up. Like is always appreciated, and I will see you on the next video.